let's go on to part C now. So part C, I'm going to draw a new sketch. I will mark the mean 24. Okay, then looks like I'm asking the probability between 16 and 26. So 16 would be to the left, and then 26 would be somewhere to the right. So I know I need this shaded region right here. So now my lower bound is 16 and my upper bound is 26. So actually this is quite nice. I can hit second vars, go to number 2, and then I can hit 16. I can pick 26, and then 24 and 8. I can hit paste. So that's exactly how you type it in the 83 as well. 16, comma, 26, comma, 24, comma, 8. Hit enter, and then we get 0.440. So I can say, if you round to 3 decimal places like I've been doing, 0.440. That represents that little shaded region right there. Now I'll make a comment. What if you drew this like on with the x-axis and then f of x here? Okay, what if you drew this whole thing? Well, you might be wondering when we hit second vars why we're always skipping over number 1, normal PDF. Well, if I hit normal PDF, okay, the x value. If I want the x value, let's just say 16. I'll mark 16 for the x value, and then mu was 24, and sigma was 8. If I mark this, and I hit enter here, PDF, that really actually just gives you the height at that value. So the height right there was 0.030. That's just the height for the value of 16. And then if you wanted to, I can do this again by hitting second var, normal PDF. You can find the x value. Well, let's just try x value of 24. What's that height going to be? That's actually going to bring you to the peak, right? It'll bring you to the peak. But knowing these, 0.049867, blah, 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 right? Knowing the heights of the curve, that's not going to help us, right? We need to use CDF in order to get the area under the curve. We want area, right? Area represents probability, okay? So we will never use PDF. I guarantee in this course, you won't be asked what the height is on the normal curve, okay? Now, if you had the uniform distribution, then you'd be looking for height. But with the uniform, it's just a nice rectangle, so the height is simpler to find. Okay, moving on to the last type of question. What is the x value that represents the top 30% of data? So all these probabilities could be converted to percentages, right? And if you have 30%, you could convert that to probability by just taking 30 and dividing by 100, or by moving the decimal place to the left twice. So you can see you could get 0.3. So what I want to do is figure out 0.3, the top, right, 30%. So I want this shaded region right here, the top 30%. I'll mark 24 again. So I'm looking for this x value, the x that represents the top 30%. Well, earlier on in part B, we saw that 30, right, earlier on we saw that 30 actually marks where the top 22.7% is, right? If you move the decimal place twice, it would be 22.7%, right? And that's in the top because it's in the right. So we know that it's going to be some value probably close to 30-ish, something like that. So that's what we'd expect. So what we need now is to do the opposite of what normal CDF was doing. All right, so let's go back in our calculator. Second vars. Number 1 and number 2, we saw what those do. Number 3, inverse norm, is actually what we'll use. We were doing the opposite of what normal CDF does. So inverse norm asks us area. Now, it may be tempting to just say, okay, my area is 0.3, my mu is 24, and my standard deviation is 8. Well, when we mark this, let's just hit enter. Well, you get 19.8. Okay, well, let's look at our drawing over here to the right. 19.8 is actually like somewhere over here, 19.8. But then we're wondering, well, I put in the area of 30%, so what is this really doing? Well, in our calculator, it always reads to the left, okay? It read inverse norm 0.3, it wanted the area to the left, okay? So then 19.8, well, that's a little bit to the left of 24. We really found the lower, this is the lower 30% marking. What we want is the top 30%. So we need to do a little bit more thinking. Well, let me draw another quick little sketch. Well, if I know that 0.3 is to the right of this x value, and the area under the curve is always 1, well, I could do 1 minus 0.3, and you get 0.7 would be the area here, right? So 0.7 plus 0.3, that adds up to 1, so I know that that's good. So how about I go second vars, pick number 3, and I put 0.7 here, because now the area to the left would really be 70%. 70% will bring us to 30% in the top. So the lower 70%, this is represented as 28, and we could write this 28.2. Okay, 28.2. Now, does this logically make more sense? So if you look at this, 28.2 makes much more sense to us, right? It's to the right of 24. And that's why drawing a little sketch will help you if you accidentally made that mistake of finding the lower 30% instead of the top 30%. Now let me show you in the 83. You can hit second vars, go to number 3 still, but then you just have to remember what to type in. Well, you need to put in the area to the left, so I can just put 0.7. I'll hit comma, and then you pick 24, comma, 8 to put in your mu and sigma. So you put the area, then mu and sigma. That's all you need to tell it. And then you get 28.2 again. And there we go. So that is the recommended way. Now, if you wanted to, you could use symmetry, right, by looking at this. So this is just a bonus idea here. So you could see everything is symmetric about the mean, right? Well, earlier on we found 19.8, right? Well, 24 minus 19.8 is about 4.2. So that little distance right here from there to there is 4.2. Well, by symmetry, from 24 to that x value, you could do 4.2. So if you just took 24 plus 4.2, well, then you'd get 28.2, which is, well, look at that, that's fancy. That is our answer. So using symmetry, you could do that as well. And you could just think about, okay, do you want the top or the bottom, right? And there we go. Thank you for watching my video.